All right, so we are talking about correlation today, which I don't think you guys have learned anything about correlation in the past, so this is probably new to you guys. But correlation is like a relationship between two things. So, for example, we have a graph over here with height and weight. So typically, not always, the taller you are, the more you're going to weigh. But obviously it's not perfect. That's not always the thing. It's just kind of typically related. So again, the taller you are, the further along you are in weight, but not always the case. You could be short and weigh a lot, or you could be tall and be super, super skinny. Okay, so not always the same thing. So it's just a relationship. It doesn't mean it's a fact. They're just correlated to each other. So a correlation is used with scatter plots. Scatter plots is like those dot plots that you see right here, so not perfectly linear, just a bunch of dots, to measure how well a line represents a set of data points. And this can determine if those two variables do have a relationship or a correlation. So does one thing kind of affect the other? Does how tall you are affect your weight? So we have a variable that's used for correlation coefficient, kind of like M is used for slope and B is used for y-intercept. The letter R is used for correlation coefficient, and I'm not going to show you it today, but tomorrow I'll show you where that R is on your calculator. It's on Desmos, but not today. We'll save that for tomorrow. And this R value will only ever be between the numbers -1 and +1. So -1 and +1 would basically mean it is a relationship, it is a fact, it's 100% true. So -1 is a perfect negative relationship and +1 is a perfect positive relationship. That's kind of hard to come by. So typically your R value is between those two numbers. It's typically a decimal. It's not normally -1 or +1. It's something in between. So those values, or that number, that decimal, is described by either a weak relationship or a strong relationship. And then also we're going to talk about a positive relationship and a negative relationship. So we're going to start with positive and negative first. Think positive and negative slope. With a positive correlation, when your points lie close to a line and they go uphill in this shape, I know it's kind of hard to see your points. I'll trace them so that way you can see them a little better. You can trace them on your paper too if you need to. But see how even though it's not a perfect straight line, you can still tell it's going up? Yeah? So that still means it has a positive slope. It's going uphill. So your R value, when I say R value, I'm talking about these decimals that are going to be between -1 and +1. No matter what it is, that R value is going to be positive if it has that uphill direction to it. So for example, you could have like 0.84. So that's a decimal between -1 and +1, and since this decimal is literally a positive number, that's what tells you it has a positive relationship, okay? So a negative correlation, if we take a look at those dots, what do you notice about these dots compared to the other ones for your positive relationship? Yeah, they're going downhill, so it's negative. So when your points are lying close to that line shape, but now I have a negative slope, or that downhill direction, your R value, it could be the same decimal, it's just literally going to be a negative number. So I'm going to pick the exact same R value I had for the last one, I'm just going to throw a negative in front of it. So this guy, positive number, positive relationship. This one, negative number, negative relationship. And then we have something called no correlation. So that's when your points do not lie close to a straight line. It's hard to tell that that's linear, right? It's just all over the place. Versus these, I know they're not a perfect line, but they kind of go straight up and straight down, correct? This is just jumbled all over the place. So your R value, it could be positive or negative. That part doesn't matter. But your decimal itself is going to be pretty close to 0. Because remember that R can be anywhere between -1 and +1. So if it's close to 0, it's going to be hard to tell which direction it's going. If I look at this picture, can I tell if it's going up or down? No. So if it's hard to tell, no correlation no matter what the actual number is. So for example, if I had like -0.05, or if I had 0.23, both of those are really close to 0. One's positive, one's negative. It doesn't matter. It's just if it's close to 0, it's no correlation. So if I take a look at these 3 pictures here at the bottom, if I'm just describing that as positive, negative, or no correlation, what would you think this first picture is right here? Negative, because it's going downhill. What about the one in the middle? No correlation. And the last one? Positive. So this positive one is a little bit more spread out than your negative one, but you can still see that uphill shape. So it's just a positive slope. Then we can get a little bit more specific and talk about those decimals that I was kind of adding to your notes on that last page. The decimal itself, the number itself, tells you how weak or strong your relationship is. So if it's strong, that means it's going to be closer to the shape of a line. Your points are going to be very close to that line shape. Versus if you have a weak correlation, your points kind of maybe make a line, but it's harder to tell. So when your points sort of make that line, it's just really spread out. Or if you have no correlation when the points kind of don't really make the line. It was this picture right here where I don't really see a line, do you? Okay, so again, weak is like you can kind of see it, it's just really spread out. No correlation, you can't really tell. So I'm going to break this into smaller categories instead of you having to know all, what do we got, 5 of those? So they have it broken down into very strong and regular strong. I'm just going to combine these and just tell you that that is strong. We're just going to say strong. We're not going to go with very strong. It's just strong. So that decimal, remember your R value is going to be anywhere between +1 and -1. So if your decimal is anything higher than 0.6, because strong starts at 0.6 and goes to 0.8, and very strong is higher than 0.8. So I'm going to say anything from 0.6 higher is going to be strong. Then I'm going to group your moderate and weak together. Moderate is kind of in the middle range, but a lot of times we stay away from the middle and we go towards this weak. So I'm going to group these two together. So moderate ends at 0.6, so it's lower than 0.6, but it starts at 0.2. So your weak relationship is anything from 0.2 to like lower than 0.6. If you even wanted to put a 0.5 there, that would be fine because 0.6 and higher is strong. So maybe I'll put a 0.5 here so we don't get confused which is which. All right? So anything 0.2 to 0.5 is weak. And then no correlation, we'll keep it as it is. It's anything less than 0.2. Anything smaller than 0.2. Now, when I'm talking about these decimals, I had the plus or minus on the strong, and then I kind of forgot to bring it down the rest of the way through. It doesn't matter if those decimals are positive or negative. Positive and negative just tell you what type of slope it is, like what we did right here. The decimal itself tells you weak or strong. So you need both pieces to be able to tell the description. So for example, let's look down here. Describe the correlation. So it says by direction is positive and negative, and strength, weak or strong, or no correlation. So if I give you the decimal R equals 0.75, First of all, is that a positive or negative number?
Positive.
Positive. And if I try to find 0.75 in my little list of numbers here, what category would it belong in?
Strong.
Strong. So I would say that this is a strong positive correlation. Yeah, are you finished?
Yep.
Perfect. You can just sit on my laptop. Thanks, Jake. All right, number 2, R equals negative 0.5. Raise your hand, don't shout it out. Do we think positive or negative, weak or strong? Camden?
Weak and negative.
Weak and negative. So if I look at that 0.5, that's lower than my 0.6. So I agree it is weak. And then I know it's negative just because it literally has a negative sign in front. That's it. Okay, so someone else, R equals negative 0.96. Ava?
Strong and negative.
Strong and negative. Good. So I agree, but I do want to talk about, because someone in my last class actually said that this one was weak, and I asked them why they thought it was weak, and they said, well, because it's negative. Negative doesn't mean weak. Negative just means your slope, right? It just means it's going downhill. Since this is 0.9, 0.9 is still in my really strong category, right? So those two things are different. Positive and negative doesn't tell you weak and strong. It just tells you if it's going up or going down. Yeah, Sam? Or you want to do the next one?
Yeah.
Go for it.
No correlation positive.
Good. That one was kind of tricky because it's less than 0.2, so it's not really weak or strong. It's just no correlation. And he did say it's positive, which because it's a positive number, but when it's no correlation, it's just so hard to tell that it's a line at all that I don't make you say positive or negative. We just say no correlation. So you don't have to have the positive or negative. Not that you're wrong, you just don't need it, okay? Number 5, who wants number 5? R equals 0.35. What do we think? Someone new. Josh?
Weak and positive.
Weak and positive. Again, weak is 0.3, that's this 0.2 to 0.5, and then positive just because it's a positive number. And what about my last one here? Caroline?
No correlation and positive.
Good. No correlation. I'm going to leave off the positive, just no correlation. But good, nice job. Okay, so if I look at these last 3 pictures, we're going to give it a name for positive and negative, and we're going to give it a name for weak and strong. So remember, strong, the closer it looks to a line, the closer your points are to each other. Weak, it can still look like a line, they're just more spread apart. So if I look at this first one, would I say positive or negative, weak or strong? So, Gavin, what do you think?
Positive, strong.
Positive and strong, I agree. So, positive and strong. So, positive because it's going uphill. Strong because your points are really close together, especially compared to the other 2. Alex, what about my middle one?
Weak and negative.
Good. Weak and negative. Now, really, for a weak relationship, this one's it's really not too bad. Once we get more practice with this today, you'll realize that this is probably in this moderate section that I kind of cut off for you. It's on the higher end of weak, but yeah, it's definitely more spread out compared to the one that we just did. So negative because it's going downhill, and weak because it's more spread out. If you wanted to say it was kind of in that moderate range, you could, but I'm just worried about weak and strong. And the last one, Camden, what do you think?
No correlation.
No correlation. And again, see if you're looking at the picture, can you even tell if it's positive or negative? No. That's why I don't really make you put the positive or negative on no correlation, because you really wouldn't be able to tell if it was in that category. Does that sound good? All right, do we have any more quick questions before we practice? Okay. We're actually going